Welcome back to this Streamlit tutorial series. Today we have part 6, which is on charts. First, we're going to start out with a little bit of a layout. We're going to use two tabs, one called Basic Chart and one called Advanced Chart, and then we're going to go through the different charts. When you run this template, it should look like the browser to the right. The first chart we have is an area chart. To create an area chart, we're going to create a little bit of random data. With this area chart data, just creating a pandas data frame with some random data. And then from here, we create the chart using the random data and the column name for X, column name for Y, and then the two colors that we want. For bar chart, we're going to use the same data as for area chart and just create a bar chart. As you can see, it's a stacked bar chart. Next up, we have line charts. To generate this, we're going to generate some new data and then do st.lineChart with the new data frame and then the x-axis, y-axis, and then colors. Next up, we have a map. To generate a map chart, you want to take a latitude and longitude and then take some random data around it and then plot it near to that latitude and longitude like you see here. We're then taking that latitude and longitude, doing st.map, the map data, lat, long. This ends up turning out like the city of San Francisco with all the red dots being the randomly generated data. Last but not least, we have a scatter plot. To do this, we're going to generate some random scatter plot data, much like how we did in all the other ones, and then use st.scatterChart to then display that data. That is it for the basic charts. Next up, we have the advanced charts, where we're using third-party packages to display the charts. The first advanced chart that we're going to take a look at is Altair chart. Let's go to the top and click to the advanced chart tab. We are going to take a look at a Altair scatter plot, where we use color and size for two different variables. As you can see, the x-axis is A, y-axis is B, and then we're sizing off of the C column and we're coloring off the C column. But if we wanted to size off of another column, we could change this to A, and now we're going to size off of the A column or the x-axis. So as you can see, as it gets farther to the left, it gets smaller. Further to the right, it gets bigger. The next chart type we're going to take a look at is a graph viz chart. Here we're going to take a look at kind of a flow diagram. This can be useful when doing UML diagrams and things like that, but I don't really use them that often. Up next, we have Plotly charts. Plotly is one of the most well-known Python plotting packages. It's also used with Dash, which is a dashboarding app. Using it with Streamlit can replace the Dash component of it. And sometimes it can be easier. It's a lot easier to throw together fast charts using Streamlit rather than Dash. But Dash is a bit more enterprise focused. Here is the Plotly chart that we're going to create. We're going to create some random data and join it together. And then we're going to create a distribution plot and defining different bin sizes for each of the three plots. So as you can see, the bin size for the blue one, the farthest on the left, is a lot smaller than the green one, the farthest on the right, because we're increasing the bin size, which will smooth the distribution for the most part. Next up, we have a PyDeck chart. I haven't ever really used this package before, but it seems like it's pretty good at geospatial data. I found a pretty interesting one where we're creating some random points around Denver. So this is the lat and long of Denver. And then we're taking that, and how PyDeck works is you draw layers around the graph. We're doing the initial view, zoom level, pitch, so angle, and then we're putting layers on top of it. So we're doing these hexagons at the points that we defined by this random data. And then it's building up because we defined it as three-dimensional. So basically all the points that reside within that hexagon are going to be counted towards it and build it up. And as you can see, it's a normal distribution around the origin of the plot. So in other words, a three-dimensional normal distribution. Next up, we have PyPlot. PyPlot is the same as Matplotlib. So probably the most common plot that you have worked with in Python. You can then just pass it into a streamlit.pyplot figure, and it will just render. I'm sure this is probably, it's just an image of the plot. Last but not least, we have Vega plot to define a Vega light chart for Streamlit, but we're defining the different kind of colors, the different kind of shapes, and then the X and Y field. We're also just using some of this Vega data set, which is just to import. Then you do st Vega light chart, and then you do the car source, which is the data set that we define. And then basically this JSON is the definition of the chart, or how you want the chart to be built. So unlike with other Python packages, you're basically defining your whole chart in a JSON object. This could be useful, honestly, now that I'm thinking of it, if you wrote these into files and then you could reuse them really easily. But I've never really used this package before, so I'm sure there's some great use cases for it. I just haven't ever had the need to do it. That is it for chart elements in Streamlit. I hope you enjoyed today's video and see you next time.